It completely on. I here follow.
Yeah, I muted all of you. If anything is there, you can chat. So let's start the content. What is the time? Take the heading. Derive an expression for the refractive index of a prism in terms of angle of minimum deviation, angle of minimum deviation, capital D, and angle of prism, angle of prism. A. So 5-mark derivation, very, very important. So let us draw one prism here. ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಬರ್ಕೋಬೇಕು. Draw the prism diagram. So this is the face, I call it as a XYZ as a principal section, and angle of prism I can call it as a A. And here is the incident light, which incident first on the face XY. Okay, incident length. After that, it will refract and it travels straight in the medium, and then again it refract. Denser to rarer nodi, away the normal anta, so it's bending downward. So for this face, this is the normal line, and for this face, here is the normal. Here normal lines kuda one point will meet at the let it be here. Okay, so this is the incidence one, and even ಈ ಕಡೆಯಿಂದ ಕೂಡ xz facing the light ಹೋದ್ರು ಕೂಡ, so it will retrace the same path. Hence I can call it as an angle of incidence I2. Okay, and this is the refraction angle 1, and this is the refracting angle 2. And here, if I produce the incident ray forward, and I produce the refracted ray, emergent ray backward, so both will meet at a same point. That is called the deviation, angle of deviation of the ಕರಿತೀವಿ. Yeah, so inside the deviation angle 1, and here deviation angle 2 will form. D1, D2. Got it? So I'll call this as a M. So PQ another incident ray. Then RS ಅಂತ ತಗೊಳ್ಳೋಣ. RS is an emergent ray. Okay, this is the picture. We have PQ, incident ray, RS is the emergent ray, small d is the angle of minimum deviation, angle of minimum deviation, and A is the angle of prism. A is the angle of prism. Got it? So X, Y, Z in the principal section, R1 and R2 are the refracting angles, I1 and I2 are the angle of incidences. Okay, you can write that I1 and I2, angle of incidence, and angle of emergence also you can see, angle of emergence respectively. Got it? So now let's start the derivation. I will give you the time. I will revise it once again after completion of the derivation. So first note so for the first phase xy, I1 is the angle of incidence, R1 is the angle of refraction. Okay. So now we'll apply the law of refraction for the first phase. Apply Snell's law. ಇದನ್ನೇ laws of refraction ಅಂತೀವಿ for the phase xy. Okay, Snell's law ಪ್ರಕಾರ ಏನಾಗುತ್ತೆ, n is equal to sin I1 divided by sin R1. So call it as a equation 1. Okay, so now look at this triangle. From the triangle QMR, okay, we can say here exterior angle D another exterior angle. Not a triangle here with the formation. I'll write it here. The QMR. This is Q. This is this is Q. Here is a M. Here is a R. Exterior angle is small d, right? Interior angles are D1 and D2. Correct. So exterior angle will be equal to sum of two opposite interior angles. So I'll write it here from triangle QMR. Okay, so we can write that D is equal to D1 plus D2. Reason because exterior angle is equal to sum of opposite interior angles. Interior angles. So let us find out what is D1 and what is D2. Now, the picture nalli. So for this point Q, okay, at Q ಏನಾಗುತ್ತೆ, vertically opposite angles are equal ಅಂತ ಆಗುತ್ತೆ. I1 is equal to D1 plus R1, right? Therefore D1 ಅನ್ನು ಏನಂತ ಬರೆಯಬಹುದು, I1 minus R1 ಅಂತ ಬರೆಯಬಹುದು. Similarly, we can also write D2 as a I2 minus R2. Got it? So substitute those two values. Therefore, D is equal to I1 minus R1 plus I2 minus R2. D is equal to, now separate the terms, I1 plus I2 minus common to R1 plus R2. So this is the equation 2. Now from quadrilateral, XQPNR. Observe the quadrilateral there, XQPNR. Okay, quadrilateral property ಏನಂದ್ರೆ opposite angles sum ಮಾಡಿದ್ರೆ 90 degree ಬರುತ್ತೆ, 180 degree ಬರಬೇಕು. Okay, so the sum of the opposite angles, I can write here A plus N. Angle A plus N, angle N should be 180 degree. Call this as a equation 3. ಅದೇ ರೀತಿ, look at this triangle QNR. Here kuda sum of the angles must be 180 degree. Okay, in the triangle QNR, sum of the angles, all the three angles, sum is 180 degree. Let's write that in triangle QNR, R1 plus R2 plus angle N is equal to 180 degree. So call it as equation 4. On comparing 3 and 4, compare the equation 3 and 4, we can write that angle A is equal to R1 plus R2 ಅಂತ ಬರೆಯಬಹುದು. Okay, from 3 and 4, here 180 is same, here angle N and N same, but here in the position of A, so here R1 plus R2. I'll call this as equation 5. Okay, angle A is equal to R1 plus R2. Now substitute this value equation 1 in equation 2. ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ r1 plus r2 ಇದೆಯಲ್ಲ equation 2 ನಲ್ಲಿ ಈ ಪ್ಲೇಸ್ ನಲ್ಲಿ a ಅನ್ನು ನಾವು ರಿಪ್ಲೇಸ್ ಮಾಡಬಹುದು. Therefore, equation 2 becomes d is equal to I1 plus I2 minus a ಆಗುತ್ತೆ. Okay, call this as equation 6. Now what is the condition we have to derive? Observe the question. Angle of minimum deviation ಅಂತ ಇದೆ. What is the meaning of angle of minimum deviation? ನೋಡಿ minimum deviation ಅಂದ್ರೆ ಇದು usually ನಿಮಗೆ practically ಮಾಡಿಸಿರ್ತಾರೆ. Okay, there is a minimum deviation curve like this. When you draw a curve between angle of incidence and with the deviation, see as the angle of incidence keep increases, incidence ಜಾಸ್ತಿ ಆದಾಗ deviation ಕಮ್ಮಿ ಆಗ್ತಾ ಬರುತ್ತೆ ಒಂದು ಪಾಯಿಂಟ್, and then it will become minimum and suddenly it will increases like this. So this point is called a minimum deviation. ಇದನ್ನ ನಾವು ಕ್ಯಾಪಿಟಲ್ ಡಿ ಅಂತ ಬರೀ. This is minimum deviation point. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, angle of incidence I1 will be equal to I2 and R1 will be equal to R2. ಈ ಪ್ರಿಸಮ್ ಡಯಾಗ್ರಾಮ್ ನೋಡಿ I1 ಮತ್ತೆ I2 ಎರಡು ಈಕ್ವಲ್ ಆದ್ರೆ ಇಲ್ಲಿ deviation value it become very minimum. Such deviation is called minimum deviation. Yeah. So here apply the minimum deviation condition at minimum deviation I1 is equal to I2, R1 is equal to R2, and small d can be replaced with capital D, right? See, capital D is the minimum deviation as I said. Therefore, ನೋಡಿ ಏನಾಗ್ಬೋದು ಈಗ equation 5 ಇದೆಯಲ್ಲ, I'll write this equation 5 as equation 5 becomes A is equal to R1 plus R2 ಇದೆ. I can write it as R1 plus R1 because R1 and R2 both are equal. So it will become 2R1. Therefore, R1 ಏನಾಗುತ್ತೆ A by 2 ಆಗುತ್ತೆ. Okay, R1 becomes A by 2. ಅದೇ ರೀತಿ equation 6 apply ಮಾಡಿ. The equation 6 becomes small d ಅನ್ನ capital D ಬರೀಬಹುದು. I1 plus I2. I can write it as I1 plus I1 minus A ಆಗುತ್ತೆ. Therefore, D is equal to 2I1 minus A. Therefore, 2I1 is equal to A plus D. Therefore, I1 is equal to A plus D by 2. See, I got the value for I1 and I got the value for R1. ಈ ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಈಗ equation 1 ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. equation 1 ಇಲ್ಲಿದೆಯಲ್ಲ, sin I1 by sin R1. Therefore, equation 1 becomes n is equal to sin of A plus D by 2. I1 ಅಂದ್ರೆ A plus D by 2 ಅಂತ divided by sin A by 2. That's all. Final derivation. Once again, I'll explain. We are going to derive an expression for the refractive index of the prism in terms of angle of minimum deviation and the angle of prism. Look at this. This is the principal section of the prism XYZ. Okay, with respect to the first phase XY, PQ is the incident ray, I1 is the angle of incidence. After that, QR is the refracted and RS is the emergent ray, which is emerging from the other phase. I2 is the second angle of incidence, you can say, or else you can also say that it is an angle of emergence. So, ಇಲ್ಲಿ ಎರಡು ನಾರ್ಮಲ್ಸ್ ಗಳನ್ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಎರಡೂ ಫೇಸ್ ಇಂದ it will meet at a one common point. Okay, let we mark it as a n. And the angle of refraction is R1, here the angle of refraction R2. If you produce the incident ray forward and if you produce the emergent ray backward, okay, so both will meet at a point. This is called the angle of deviation. So what is angle of deviation, Andra? It is the angle between the incident ray extended and the emergent ray uh, produced backward. Got it? The angle made between them is called angle of deviation. And this is the deviation angle 1, deviation angle 2. Understood? And at Q, so vertically opposite angles are equal. So I can write this I1 is equal to D1 plus R1. You get the D1. And for the other phase, you get the D2 like this, I2 minus R2. Now use the Snell's law. N is equal to sine I1 by R1. And from the triangle QMR, use the exterior angle is equal to sum of opposite interior angles property. D equals D1 plus D2. Substitute the values here and separate the I terms and the R terms from the quadrilateral XQNR. Observe the quadrilateral here in the diagram XQNR. Sum of the opposite angles, right, are 180 degree. So A plus N becomes 180. ಹಾಗೇನೆ in the triangle QNR, ಈ triangle ನಲ್ಲಿ sum of all these three angles are 180 degree. So R1 plus R2 plus N becomes 180. So from these two equations, we can write that A equals R1 plus R2. Now I am substituting this A value in the equation 2. So it becomes like this. I call it as equation 6. Now for the minimum deviation condition, at particular angle of incidence, okay, the incidence and the emergence angle both will be equal and both the refracting angles also equal. So that point we get the minimum deviation value. So use that condition, substitute in the equation 5 here and substitute in equation 6. You will get the R1 and you will get the I1 value. After getting the R1 and I1 value, substitute in the equation 1, Snell's law, sin I1 by R1. Then you will get the final answer. Any doubts here in this step? Very, very important. 5 mark it is. If you have any doubts, you can ask. Yeah. Next is for thin prism. Thin prism. The meaning of thin prism is whose angle is very small. Those prisms are called thin prism. Okay. So here, the prism is said to be thin. Said to be thin if its angle is very small. Angle is very small. Okay, like nearly 10 degree or less than 10 degree, like that. So for a thin prism, we can neglect that the sign ratios. Okay. So for thin prism, so what we got the formula, n is equal to sine a plus d by 2 divided by sine a by 2. Right? Sine a by 2. Just a minute. Okay. Since angle of prism is very small, so for small angles, the sign ratios can be neglected. Angles sine theta approximately equal to theta. Therefore, I can write them as a plus d by 2 divided by a by 2. To do it cancel, a plus d divided by a, right? Therefore, your NA minus A and taking the A common, A into N minus 1 is equal to D. Okay. So in general, we can find out for a thin prism the deviation with this formula, A into N minus 1. This is for a thin prism. Next concept we have is rainbow. Rainbow. Now we have the rainbow ನೋಡಬಹುದು ಡ್ಯೂರಿಂಗ್ rainfall or after rainfall. ಹೌದಲ್ಲ? ಸೊ rainfall ಆಗದೆ ಹೊರತು ನಾವು rainbow ನೋಡೋದಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. So what is the reason for the formation of the rainbow in the sky? Actually, it is the combined effect. Okay, combined effect, light effect. ಯಾವ್ದು refraction, dispersion, internal reflection. ಈ ಮೂರು phenomena occur ಆಗುತ್ತಲ್ಲ. Hence, we see the rainbow there. So we can say that it is the spectrum produced. It is the spectrum produced by refraction, dispersion, and internal reflection. Internal reflection. Okay, of sunlight by the raindrops. Raindrops. This is the rainbow definition. Now, what is rainbow? So, what are the conditions to observe the rainbow? Okay, next question. Conditions to observe rainbow. ಮೊದಲನೇ condition, it is observed during the rainfall or after rainfall. After rainfall. The second condition is sun should be shining in one part of the sky. Sun should be shining in one part of the sky. Sun illa andre rainfall agli after rainfall agli sun illa andre rainbow ಕಾಣೋದಿಲ್ಲ. Sun should be shining in one part of the sky. Okay, and raining must be in opposite part of the sky. Opposite part of the sky. Sun opposite ಆಗಿ rain ಆಗ್ತಾ ಇರಬೇಕು, ಮಳೆ ಸುರಿತಾ ಇರಬೇಕು. ಅವಾಗ ಮಾತ್ರ ನಮಗೆ ರೈನ್ಬೋ ಕಾಣೋ ಚಾನ್ಸಸ್ ಇದೆ. ಸನ್ ಒಂದ್ ಕಡೆ ಇದ್ರೆ ರೈನ್ ಅದಕ್ಕೆ ಆಪೋಸಿಟ್ ಬೀಳ್ತಾ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸಿ ದ ರೈನ್ಬೋ. ಸೊ ಈ ರೈನ್ಬೋದಲ್ಲಿ ಎರಡು ರೀತಿ ಇದೆ. ಒನ್ ಇಸ್ ಪ್ರೈಮರಿ ರೈನ್ಬೋ ಅಂಡ್ ಸೆಕೆಂಡ್ ಒನ್ ಇಸ್ ಸೆಕೆಂಡರಿ ರೈನ್ಬೋ. ಪ್ರೈಮರಿ ರೈನ್ಬೋ ಆಕ್ಚುಲಿ ತುಂಬಾ ಥಿಕ್ ಆಗಿ ಡೆನ್ಸ್ ಕಲರ್ ಅಲ್ಲಿ ಕಾಣುತ್ತೆ ನಮಗೆ, ಅಂದ್ರೆ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅದರಲ್ಲಿ. ಬಟ್ ಸೆಕೆಂಡರಿ ರೈನ್ಬೋನಲ್ಲಿ ಇಂಟೆನ್ಸಿಟಿ ತುಂಬಾ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಓಕೆ, ಯಾಕೆ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. ಹ್ಯಾವ್ ಯು ಕಾಪಿಡ್ ದಿಸ್? Next, types of rainbow. Okay, there are two types of rainbow. One is primary rainbow and one more is secondary rainbow. Primary rainbow, ಮೊದಲನೇದಾಗಿ. The primary rainbow. So primary rainbow ಬಗ್ಗೆ ಕೆಲವೊಂದು ಪಾಯಿಂಟ್ಗಳನ್ನ ತಿಳ್ಕೊಳ್ಳೋಣ. ನೋಡಿ primary rainbow ದಲ್ಲಿ here there are two refractions and one internal reflection of light. Okay, it is formed due to two refractions and one internal reflection. Internal reflection of light. Okay, so ಹೇಗಿರುತ್ತೆ ನೋಡಿ, ಇದೊಂದು ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೊ ಇಲ್ಲಿ ಟೂ ರಿಫ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ ನೋಡಿ, ಲೈಟ್ ಹೀಗೆ ಬರುತ್ತೆ, ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತೆ, ಮೊದಲು ಬೆಂಡ್ ಆಗುತ್ತೆ, ಈಗ ಇಲ್ಲಿ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ, ಅಗೈನ್ ಇಟ್ ವಿಲ್ ಬೆಂಡ್. ಓಕೆ, ರಿಫ್ರಾಕ್ಟ್ ಆಗಿ ಹೊರಗೆ ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಸೆಕೆಂಡ್ ರಿಫ್ರಾಕ್ಷನ್. ಡೆನ್ಸರ್ ಟು ರೇರ್ ಬರ್ತಿರುತ್ತೆ, ಸ್ವಲ್ಪ ಅವೇ ಬಂದಿರೋದು ತೋರಿಸ್ಬೇಕು. Just here is this part. Here is an internal reflection. Again, like this. So here is a one refraction. Here is a one refraction, and this is a total internal reflection constant. Okay, one total internal reflection ಇರುತ್ತೆ. ಈ ರೀತಿಯಾದಾಗ ನಮಗೆ ಪ್ರೈಮರಿ ರೇನ್ಬೋ ಬರುತ್ತೆ. ಸೊ ಈ ತರ ರೇನ್ಬೋನ ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು ಅಂದ್ರೆ, ಔಟರ್ edge of this rainbow is ರೆಡ್ ಕಲರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಇನ್ನರ್ ಎಡ್ಜ್ ವೈಲೆಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಇನ್ನರ್ ಎಡ್ಜ್ ಇಸ್ ವೈಲೆಟ್ ಆರ್ ಬ್ಲೂಯಿಶ್ ಕಲರ್ ಕಾಣ್ತಿರುತ್ತೆ. And its intensity is more. ಕಲರ್ ತುಂಬಾ ಡೆಪ್ತ್ ಅಲ್ಲಿ ನೀಟಾಗಿ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ. ಇಂಟೆನ್ಸಿಟಿ ಇಸ್ ಮೋರ್. ಈ ತರ ರೇನ್ಬೋಗಳೆಲ್ಲ ಪ್ರೈಮರಿ ರೇನ್ಬೋ. ಕಾಪಿ ದಿಸ್. The next type is secondary rainbow. Secondary rainbow. ಈ secondary rainbow ನಲ್ಲಿ two refractions ಇರುತ್ತೆ ಮತ್ತೆ two internal reflections ಇರುತ್ತೆ. It is formed due to two refractions and two internal reflections. Two internal reflections. Okay, ಹೇಗಿರುತ್ತೆ, ಡಬಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ಬೇಕು. Okay, so same draw. The light first it will go and it will refract. First reflection illagutta, second reflection, okay, like this, and again it comes to the denser medium. So this is the one point of internal reflection, TIR ಆಗ್ತದೆ, ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಇಲ್ಲ ಆಗ್ತದೆ. ಈ ತರ ಡಬಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ ಲೈಟ್. So this is the two refraction point and two internal reflection points. So we have outer edge is violet. Whereas inner edge is red. Opposite primary line. But ಇದು ತುಂಬಾ ಡಾರ್ಕ್ ಆಗಿ ಕಾಣೋದಿಲ್ಲ ಅಷ್ಟು. ಓಕೆ, ಇಟ್ಸ್ ಇಂಟೆನ್ಸಿಟಿ ಇಸ್ ಲೆಸ್. ತುಂಬಾ ಬ್ರೈಟ್ ಆಗಿ ಏನು ಕಾಣೋದಿಲ್ಲ, ಕಲರ್ಸ್ಗಳು ತುಂಬಾ ಲೈಟ್ ಆಗಿ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ. Intensity is less for this. Now, the next concept, we are learning about the spherical surfaces. Spherical surfaces. So related to optical medium we study. Okay. So ಏನು spherical refracting surface ಅಂದ್ರೆ ಅಥವಾ spherical surfaces ಅಂದ್ರೆ it is a refracting medium whose curved surface is a part of the sphere. Okay, or else it is a refracting medium, at least one part of it must be curved, spherical ಆಗಿರಬೇಕು. ಅದನ್ನ spherical refracting surface ಅಂತ ಕರೀತೀವಿ. So it is an optical medium which has at least one curved surface. Okay. Forms part of sphere. So here we can find out the two types. One is a convex spherical surface. Second one is concave. Convex spherical surface like this. You can see. The other side is with irregular shape. Okay. So, but this part is appeared to be part of a sphere which is curved. So, ಇದು rarer medium ಆಗಿರುತ್ತೆ, ಈ ಕಡೆ denser ಇರುತ್ತೆ. So, it is convex towards the rarer medium, right? So, it is a spherical refracting surface which is convex, ಅಂದ್ರೆ bulged outward towards the rarer medium. This is a convex spherical surface. ಅದೇ ರೀತಿ concave spherical surface. Concave ಅಂದ್ರೆ ಒಂದು ಪಾರ್ಟ್ inward bulge ಆಗಿರುತ್ತೆ. It is a cave shaped. Okay, towards the rarer medium, it is concave. Here is a denser medium. So these kind of lenses are called concave spherical surfaces. Okay, which is imagined to be a sphere. ಹಾಗಾಗಿ ನೋಡಿ, ಇದರಲ್ಲೂ ಕೂಡ ನಾವು radius of curvature, center of curvature, pole, okay, focus, everything we can identify. So I'll explain you those things now. Suppose if I take an example of a concave spherical surface. So here we can imagine a spherical shape like this. Here it comes a center of curvature. Here it will become a pole, and pole to center becomes a radius of curvature. Right? The distance between pole to center of curvature is radius of curvature. But ಅದೇ ರೀತಿ convex ಗೆ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ? I take convex spherical surface. Here it is that one side as convex. So I can imagine this also as a part of a sphere. ನೋಡಿ, ಇದಕ್ಕೆ radius of curvature right side ಬರುತ್ತೆ. Here pole, here is the center of curvature, radius of curvature, come towards right. So for the convex surfaces, radius of curvature is positive. But here for the concave spherical surfaces, radius of curvature is negative. Within the input code. Okay. This is concave and this is convex. Understood? Any doubts here? Yeah, moving to the very important derivation now. Yes. Let's go to the derivation. Take the heading. Derive the relation between U, V, N, and R. U on the object distance, V is image, N is the refractive index, and R is the radius of curvature. For the refraction at spherical surface. Spherical surface. So here by using convex spherical surface. So I'm using the convex spherical surface now to derive this relation. So ನಿಮಗೆ exam ಇರೋದು ಕೂಡ ಇದೆ. Let's draw the convex spherical surface. Very important. Please keep drawing it. Draw the convex. One side is a convex spherical surface. It is. Another side is irregular. That will be. And here is a light which is passing through the principal axis, right? So I can mark this as a pole here. And I'll place the object here. So this is an object. And from the object, light will form on a surface. From the object, first light will form on a surface and it forms an image. That image forms a area. And if you draw the normal, it will meet the center of curvature. This is light ray direction. Object in the first face ಮೇಲೆ ಬೀಳ್ತಾಗ let the face be xy. xy ಅನ್ನೋದು spherical refracting surface. And this is the pole I'm taking. Okay. And this is the normal line. Here is the angle of incidence, I. And here is the angle of refraction, R. And if you draw the normal, it always meets the center of curvature. And incident ray, the refract agata. After the refraction, it forms the image which is inside the spherical surface. So here outside refractive index, I can take it as an N1. Inside, can take it as an int. Okay. Now with respect to the object and the principal axis here, the light is also keep moving along the principal axis. With respect to these two, I'll take the angle alpha here. With respect to the image, I'll take the angle beta. And with respect to the center of curvature, I'll take gamma. Now between the R and gamma, don't get confused. Gamma this one. At the center of curvature, there is gamma. With respect to object alpha, with respect to image, it is beta. Okay. And object distance is this one. and pole to center is the radius of curvature, and pole to image is the image distance. Okay, this is about the diagram. Please copy the diagram, copy it. I applied the Snell's law here and I cross multiplied. I got this equation 1. Now we are considering the paraxial ray. Paraxial ray means this is the ray which passes very close to the principal axis. When it passes very close to the principal axis, the angles will become very small. Okay, then we can neglect this sign ratios. So now using that concept for paraxial rays. For paraxial rays, the angles will become very small, very negligible. We can say that very negligible means very small. Therefore, sine I approximately equal to I, and sine R can be written as a R. Therefore, equation 1 becomes N1 into I is equal to N2 into R. Call it as an equation. Now we have to find that I and R value. So by considering the previous diagram here, see, if I consider this triangle, okay, I'll call this point as a since a normal meeting point, right? So I'll call it as a L. So consider this triangle ONP. So in this triangle, you can find out the exterior angle, right? The exterior angle by considering this ONC. ONC. Exterior angle is I. Sum of the opposite interior angles are alpha plus gamma. And similarly, I can consider CIN, this triangle. I can find out the gamma as an exterior angle. So that will be equal to R plus beta. So first I'll consider this triangle ONC. So in triangle ONC, exterior angle is I. I is equal to sum of opposite interior angle. So it becomes alpha plus gamma. Next, in triangle, the next triangle, which one? NCI or CIN. The gamma is the exterior angle. Here, R plus beta will be the sum of interior angles. So this gives rise to R value. R value becomes gamma minus beta. Okay. So call it as equation 4. Now I got the I value, I got the R value, substitute in equation 2. Substitute 3 and 4 in 2. Therefore, equation 2 becomes N1 into I, alpha plus gamma plus N2 into R, so is equal to N2 into R. R is gamma minus beta. Multiply this to N1 gamma into gamma minus N2 beta. Now take the terms towards one side, the gamma terms to one side. N1 alpha plus N2 beta I can write, and N2 gamma minus N1 gamma. Therefore, N1 alpha plus N2 beta is equal to, take gamma common, then it becomes N2 minus N1. So call this one as equation 5. Observe the simplification. We found the I value and the R value. We substituted those two values in the equation 2. And we multiplied to each terms and we separated the gamma terms to one side and we got this equation 5. Now we have to find what is alpha, what is the beta, and what is the gamma. Okay. Again, we have to consider paraxillary situation. Okay. Observe here the diagram. I want to find this alpha. Okay. If I consider this line as a very paraxillary, then this NP line almost appear to be straight. It will not appear as a curved line. Okay. We can imagine this NP as a straight line. Then I can consider tan alpha for this, right? Tan alpha become opposite by the adjacent. Similarly, I can find tan beta opposite by the adjacent pi. Similarly, tan gamma. So by all these three triangles, we can find out alpha, beta, and gamma. But the thing is, we have to consider for paraxillary situation. For a paraxillary NP, this line can be considered as a straight line. Let's do that. For paraxial trace. Okay, NP is considered to be a straight line. Right. Therefore, therefore, from triangle NOP, I can find out the tan alpha there. So PN by PO bರುತ್ತೆ. So my tan alpha in this triangle opposite divided by the adjacent PN by PO. Since it is a paraxillary, that tan ratios can be neglected. I can just consider it as a alpha. And again, from the triangle, consider this PIN. From the triangle PIN, can consider tan beta. Again, perpendicular side is common, PN by PI, it is a beta. And from triangle PCN, also the diagram here, PCN. Here is a gamma, so tan gamma. Tan gamma is equal to PN divided by PC. So this is a gamma. Now substitute all these values in this equation 5. Therefore, equation 5 becomes N1 into alpha. Alpha is Pn divided by Po plus N2 into beta is there, right? Beta is Pn divided by Pi is equal to gamma into N2 minus N1, right? So gamma under Pn minus Tc into minus N1, Pn by Tc. I can take the Pn common this side, left hand side, and Pn will be cancelled, right? All the sides Pn will be cancelled. Then I can write that. Sure, it is cancelled. It becomes N1 by Po, N2 by Pi. Little lengthy derivation. but the steps are very simple. Just basic mathematics ಅಷ್ಟೇ ನಿಮ್ಗೆ ಬೇಕಾಗಿರೋದ್ರಲ್ಲಿ divided by PC. Now find out the values of PO, PI, PC according to Cartesian sign conventions. Okay, PO ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಗುತ್ತೆ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ. ಟುವರ್ಡ್ಸ್ ಲೆಫ್ಟ್ ಇರೋದ್ರಿಂದ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. PC radius of curvature and PI is the image distance. These two are positive. Okay, you can call this as a equation 6. Now, by applying Cartesian sign conventions, we can write that PO is equal to minus U, PC is equal to plus R, and PI is equal to plus. Therefore, equation 6 becomes, equation 6 substitute ಮಾಡಿ N1 means refractive index of the object space, PO minus U, plus N2 divided by V ಅಂತ ಇದೆ, right, is equal to N2 minus N1 divided by PC. PC means radius of curvature. Or we can also write this as a N2 by V minus N1 by U is equal to N2 minus N1 divided by R. This is the final expression. Final derivation. Okay. So in general, we write that what is the N2? N2 ಅಂದ್ರೆ ನೋಡಿ, refractive index of the denser medium, right? ಅಂದ್ರೆ ಎಲ್ಲಿ ಇಮೇಜ್ ಬಂದಿದೆಯಲ್ಲ ಅದು, this point we called as a refractive index of the image space ಅಂತ ಕರಿತೀವಿ. N1 ಅನ್ನ refractive index of object space ಅಂತ ಕರಿತೀವಿ. Okay, so we can convert into words. N2 is the refractive index of image space divided by V ಅನ್ನೋದು image distance. General formula we use it as plus C plus refractive index of object space divided by U means object distance is equal to N2 minus N1. N2 minus N1 is the difference in the refractive index divided by R is the radius of curvature. Yeah, I'll revise it once again. See, we are proving the relationship between UV and R by using the convex spherical surface. This is the convex spherical surface. We get the object in front of the curved surface, and after refraction, we are getting the image here. And if you draw the normal, it will meet the center of curvature. With respect to the object, okay, the angle formed with respect to incident ray and through the principal axis is alpha. And with respect to image, the angle formed is beta, and with respect to center of curvature, the angle formed is gamma. Start from Snell's law, sin I by sin R, N2 by N1. Okay, so cross multiply these two, you'll get this equation. Now for paraxial ray condition, the ratios of signs can be neglected. So you can write it as N1I is equal to N2R. Now consider the two triangles ONC and CIL. Use the exterior angle property for the triangles. Exterior angle is equal to sum of two interior angles. Find the I and find the R. Substitute these two in the equation 2. Multiply them. Okay, and keep the gamma terms to separate. you will get the equation 5. After getting this, now find out alpha, beta, and gamma. To find out alpha, beta, and gamma from this triangle, again you should consider paraxial ray condition. Paraxial ray means it is the light ray which passes very close to the principal axis. Okay, so that this NP, the curved part, will be considered as a straight line for a paraxial ray condition. Okay, and these angles are also very small, alpha, beta, gamma. Okay, and to find out those angles, we can consider tan alpha, tan beta, tan gamma in these triangles. Find out the tan alpha, tan beta, tan gamma. After finding alpha, beta, gamma, substitute in the previous equation here. Then you'll get the equation 6. Now use the Cartesian sign convention. Substitute and rearrange it. You'll get this equation. And in general, we can write this formula for spherical surfaces. And this general formula even applicable for concave spherical surface also.